Okay, hello everyone. I am doing another example video. In this situation, I am showing you guys how to use your cell phone right here, holding facing down the camera. This is a paper. I am going to use ruler and the pencil pen to show you how to create a problem solving video. So I am going to pretend like a student solving this problem. Okay, I am solving this problem as a part of Dr. Weliweriya's request to generate a video solving a physics problem. I picked this problem, the example bike ride. This problem talks about a professor riding a bicycle. Finally, it asked me to find the displacement vector and the direction. In order to get there in part B, it gives me the hint to find the components. So, in order to get there, I did create my axis. I picked north, east, south, west with a scale. I am going to be this professor riding this bicycle. So I will first mark down the lengths and the directions, the magnitudes where this guy is going. So starting off, he goes on south pole 0.5 kilometers right here. I am starting right here at the origin. He is going down for 0.5 kilometers. This is 1/2 kilometer. Then he turns left. From here, if I am the person riding this bicycle, turn left means I am going this way. He is going for 3 kilometers. Okay, right from here for 3 kilometers means 1, 2, 3 right here. Here we have 3 kilometers. Then he takes another left just for 30 degrees. He is riding for 4 kilometers. Let me mark that. Okay, let me say if I extend this line, 30 degrees means like here. If I go this way, it is, let's say in this direction for, let's say right here. This is 4 kilometers. This is 30 degrees. Okay, so afterwards he turns due west, moves for 1 kilometer right from here. Due west means in this direction. He is going for 1 kilometer right here. This is 1 km. Okay, so we have everything. This is the start. This is the end. Final position right here. The vector starting from the start to the ending. From here, this is what we talked inside the classroom. This is the vector, displacement vector delta r. Because we are talking in 2 dimensions, here we have the delta r, not either x, not only y, delta r. So in this situation, since we start at the origin, at the starting point, we have that vector, displacement vector starting from the origin. So as we talked in if we need to find the components, all we have to do, projections to the axis, projections to the axis. That's all we have to do. If I find this height right here, this guy, that is going to give me the north component. North component. In other words, this is my y component, delta y. If I get this length right here, this is the east. east component. This is the east component. In other words, this is my delta x. That's all we need. Okay, so let's go ahead and do the math. If I need to find my delta x, I am thinking about everything horizontal. I am thinking about only the x components. I do have, starting right here, going for 3 kilometers. Okay, I am right here, 3 kilometers, 3 km. From this point, it is a vector with an angle. I need only the east component, x component. To the direction of the angle, it is going to be a cosine. This is still in the positive direction, so 4 kilometers into cosine, the angle is 30 degrees. Okay, so if I do that, I will get to the projection right here. I will get to this point, but I need up to this part. From here to here, he is moving in the negative direction. So negative 1 kilometer will do it. I come back. Here I have from here to here, which is the east component I need. When I do the math, I will get this is equal to 5.5 kilometers. This is because I did this math earlier. Okay, next delta y, which is the north component. If I get 4 times sine 30 degrees, if I get this guy, this is the 4 vector. Starting from here, if I get the away from the angle component, away from the angle, so the y component, I am thinking about this whole part, but I need this much. That's all I need. So if I do this part, I am getting everything, but this is moving in the negative direction. If I subtract 1/2 kilometer from this part, if I subtract this guy, I am getting the north component delta y. This is equal to 1.5 kilometer. Again, this is because I did this part ahead of the time, the calculation. So once I have everything ready, this is part A. What is the x component or the east component? This is part A. What is the east component or the x component? What is the north component or the y component? Part B is about what is the displacement vector delta r. From the Pythagorean, we all know delta x squared plus delta y squared square root gives me the displacement vector. All I have to do, go ahead and substitute 5.5 squared plus 1.5 squared square root gives me, in terms of kilometers, displacement vector magnitude. I'm sorry, this should be the magnitude. Displacement vector magnitude is equal to 5.7 kilometers. If you want to leave it as 5,700 meters, that is also fine. This is the answer. Next part, what is the angle theta? We are measuring angle theta right here, theta, relative to the horizontal axis or relative to the east. How many angles we should go northward? So here we have already defined formula. Theta equals tangential inverse y component divided by x component. This guy is equal to tangential inverse. If I substitute 1.5 kilometers divided by 5.5 kilometers. Kilometer cancels out. It gives us a unitless or the dimensionless, this guy. Theta, which is equal to 15 degrees. We have it from east towards north. That's how we have this theta angle. So this guy has, we define the number and north of east. So that's all solving this problem. All I did, everything what I am doing, what is the reason for doing that? Every step I am doing here, what I am doing, what is the reason behind doing that? That's all you have to do. Clearly show the work, clearly speak, so the grader, the GTA, GLA, me, we can hear you. Okay everyone, good luck to you all. I am looking forward to see many of your videos solving problems. Okay, until for now, goodbye everyone. I'm going to stop the video.